Students, so today we are going to do numerical on the chapter lenses. So this is a lens diagram which is shown here. So इस diagram में ये object है, ये image है. Object जब f1 और 2f1 के बीच में होता है, image is always beyond 2f2 and it's magnified. So how to make this diagram, that is in another video which you can see it later on and understand how these diagrams are made. But now let's just focus on this one diagram and understand some basic terminology. तो ये object है, वो image है. So distance of the object from the center of this lens, the principal axis, it is known as u. It is denoted by u, and the distance of the image is denoted by v, and the focal length is written with f. So these three things are in red are very important. Object के distance को u से denote करते हैं, image के distance को v से, और focal length of the lens is denoted by f. Okay. So now you have to remember your coordinate geometry. Coordinate geometry, this is x-axis, this is y-axis. So this is the positive side of the x-axis, this is the negative side of the x-axis, this is the positive side of the y-axis, this is the negative side of the y-axis. So similarly in our lenses, we do the same thing. The distance measured towards the left, which is object, is negative. The distance measured toward the right, which is image, it's positive. The distance measured towards the top, which is height of the object, again it's going to be positive. The distance towards the down, which is height of the image, it is going to be negative. And the focal length does not depend on that. The measuring of focal length depends on whether it's convex lens or concave lens. अगर convex lens है तो focal length positive रहेगी, अगर concave है तो it is going to be negative. Okay, it is little bit too much for you to digest in, but just understand this according to the rules of coordinate geometry. जो right hand side में हम लोग measure कर रहे हैं positive, जो left hand side में कर रहे हैं negative, जो top की तरफ measure कर रहे हैं positive, जो bottom की तरफ measure कर रहे हैं negative. So object top की तरफ है इसकी height, तो ऑब्जेक्ट हाइट इज गोइंग टू बी पॉजिटिव. इमेज की हाइट डाउनवर्ड है, सो नेगेटिव. डिस्टेंस की बात करें, ऑब्जेक्ट डिस्टेंस नेगेटिव, इमेज डिस्टेंस पॉजिटिव. सो यू हैव टू रिमेंबर दिस एंड देन वी हैव टू do the numerical. So let's start with one numerical. You will understand this. Okay, so suppose there is I'll read the question for you and let's just write whatever is given to us. So suppose an object is placed vertically at a distance of 20 centimeter from a convex lens. An object is placed 20 centimeter vertically from a convex lens. So 20 centimeter object का distance है, तो object का distance हमें given है, so u. So u is taken as negative because in the left hand side. So let's take minus 20 centimeter. If the height of the object is 5 centimeter, height of the object will be denoted by h1. It is 5 centimeter and height of the object is positive because upwards above. And the focal length of the lens is 10 centimeter. Focal length, now they have said convex lens, so focal length is going to be positive 10 centimeters. So next the question is, what is the position, size and nature of the image? So we have to find the position, size and the nature of the image. And is the image going to be longer than the object? So we have used all this information here. U we have taken negative, height one of the object we have taken positive, focal length we have taken 10 centimeter positive. Now let's move on. So now the next part is the formula. So you have to remember there are only two formulas that we are going to use here. The third formula in this chapter, that is about power, that we will do later on. So the two formula, the first formula is lens formula, which is 1 upon f is equal to 1 upon v minus 1 upon u. This is the formula that we have to remember. The next formula is of magnification. The formula for magnification is h2 upon h1 and it is equal to minus v upon u. h2 upon h1, height of the image, height of the object, v and u, distance of object and image, that you know. So we can cross multiply here if you know three things. So we already know h1, we already know u, so all we have to do is find v, because we have to find the image position. So if we find v, because this three things we have to find for image, so we will use the first formula to get the answer. So let's calculate. So let's use the formula 1 upon f is equal to 1 upon v minus 1 upon u. So let's put the values. Focal length is 10, v have to find, and u is minus 20. So minus minus will become positive, so this can be written as 1 upon 10 is equal to 1 upon v plus 1 upon 20. Minus minus become positive, so I want to find 1 upon v, so I'll send this entire thing there. This entire thing will go there. Okay, so this entire thing will go there, so 1 upon 10 will remain as it is. This 1 upon 20 will go there and become minus 1 upon 20 is 1 upon v. So let's do the cross multiplication. If you want, simply you can multiply 2 to this side. This will become 2 upon 20, base will become common. Or if you don't want to do that, another way you can do cross multiplication. So 20 ones are 20, 10 ones are 10, 20 tens are 200, 1 upon v. 20 minus 10 is 10 upon 200, 1 upon v, 0 0 cut. So v, let's do the reciprocal. 1 upon 20 is the answer, so v will go up, 20 will go up, so v is equal to 20 centimeters. So I got my image distance as 20, and it's positive because image is on the right hand side. So it was a simple calculation. 1 upon f is equal to 1 upon v minus 1 upon u. F value I have put, it was given to me. U value was given to me minus 20, minus minus become positive. This thing I sent there, it become negative. Cross multiplication, and just by reciprocating it, we got the answer as 20 centimeters. So I got my v now. So v, that is position of the image. So if you look, object was 20, image is also 20. So object was at 2f1, image is also at 2f2, because only in the case of when the object is at 2f1, the image will be at 2f2, same distance. Only in one case, both are at same distance. Now we need to find out the size of the image. And nature we will get to know once we get to know the size of the image. Nature already we know because it's positive, so it's real and inverted, because it is on that side. Only in one case, if the image becomes negative, so the image is on the same side of the object. In that case, we call it as not real, we call it as virtual image. But now we got on the right hand side only, so we call it as real image. Okay, moving on, let's find out the height of the image. So like I told you, the height of the image is calculated by using this formula. h2 upon h1 is equal to minus v upon u. So height of the image is h2, that you have to find out. Height of the object is 5. Now we got 20, so minus 20 upon height of the object, it's 20. Height of the object, u is also 20. So let's do the calculation. So if you are putting minus here was just for the object, so minus was in the middle. So if you do the cross multiplication, so height of the image is going to be minus 5. So minus because it's downwards is going to be negative. So height of the image is going to be minus 5. And if someone says what is the magnification? Magnification is nothing but this ratio. So height of the object is also 5, image is also 5. So magnification is nothing but minus 1. Magnification is same, like the object is same size, image is also the same size. And regarding the nature, like I said, the image is real. Okay, one more formula is here, the formula for power of the lens. The third formula is power of the lens. Power of the lens, the formula is very simple. Power is equal to 1 upon f, focal length. But the focal length should be in meters. That is the only condition. Focal length should be in meters. So focal length kitna tha? 10 centimeters. So 10 centimeters, if I have to convert it into meters, I have to divide by 100. So this will be 0.1 meters. So let's put here 0.1. So I have to remove the decimal because I have to have a number and not decimal on the denominator. So let's multiply this by 10, multiply this by 10. So because of the multiplication of 10, this will become 1. So 10 upon 1, which is nothing but 10. So power is 10, and power is measured in terms of diopters. So it is 10 diopters. So power of the, according to the power, according to this formula, the power is 10 diopters. Power is measured in terms of diopter. That's it.